In this video, we're going to look at how we can use the first quadrant of the unit circle to derive the entire unit circle. Of course, here we have our quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you missed it, the video before this, we derived the first quadrant, so you may want to go check that out if you have no idea what we're talking about here. Alrighty, so now the unit circle is very much symmetric, and that's the property that we're going to utilize to help us to derive the entire circle. What do I mean when I say symmetric? So this is your y-axis and this is your x-axis. So the first quadrant is going to be symmetric to the second quadrant in that the y-axis is serving as a mirror. And so if we recall, looking in the mirror, it's an axis of symmetry. And so that means whatever we see on the left is going to be portrayed on the right. And vice versa, whatever is on the right is going to be portrayed on the left. So for instance, if I use this 90-degree line or the y-axis, let me use a highlighter here. This is my mirror. Now, if I were to imaginarily flip or reflect this, then I'll have this line here that corresponds to my 60-degree. And then this line will correspond to the 45-degree. And then this line will correspond to the 30 degrees. More importantly, what we're going to be looking at is the fact that this point is going to be symmetric to this point. And when I say symmetric, it's going to be serving as a mirror. And so if you look in the mirror, you're going to see that reflected on the left. So that means that this intersection will be the same on the left. So you'll have 1/2 √3/2. Likewise, the middle dot or the middle intersection is going to correspond to the middle intersection on the left. And so that means that this is going to be √2/2, √2/2. And then our last dot is going to correspond to the last dot. And so this is going to give us √3/2, 1/2. There's one difference though, because if you recall with our XY plane, the points in the first quadrant, it's going to be positive, positive. And again, if you think about it, that's for your X and your Y coordinate point. And then the point in the second quadrant, that's actually going to be negative, positive. Now, since the point in your second quadrant is negative, positive, well, that means that my X or the first quadrant, coordinate rather, is going to be negative. So even though we're flipping, we still have to observe the properties of our XY quadrant. So that way we are able to identify, well, these are my actual intersections between these angles and the unit circle. Now, one might be asking, well, what about the degrees and the radian measure? Well, let's think about it. And so if we're still doing our symmetry and corresponding angles, then notice that between 60 and 90, we have a 30-degree angle here, right? So between 90 and this angle here, we should have 30 degrees as well. So if I want to know what this angle is, this angle here, well, I would do 90 plus 30. And so that's going to give me 120. So that means that this angle is going to be 120. All of our angles, we are going to have our initial side to be here, the x-axis for all of our angles. Let's use another color. Let's say orange. This is going to be my initial side for all of my angles. Now, we're going to continue this notion. The middle angle is going to be 45 degrees away from, so here, that's going to be 45 degrees from 90. And so that means that we're going to do 90 plus 45, and that's going to give us 135. So this angle here is going to be 135 degrees. And then also, we're going to do the same thing. If you would think about it, notice that between 90 and 30, there's an angle of 60 degrees. So, or in other words, you can say that this angle here is 60 degrees away from 90. So if I really want to know what this entire angle is, I would do 90 plus 60. And that's going to give me 150 degrees. So this angle here is 150 degrees. And we should be familiar with the fact that angles on a straight line measure 180. So this angle here is going to be 180 degrees. So that's how we can come up with our angles. But of course, we're going to need radian measures, right? And also note that here, we're still using the fact that this is a unit circle. So if we were to go from the center of the circle to the edge of the circle, then this would be a length of 1. But if we're in the left side of the x-axis, or if we're on the left side of the x-axis, that means this is going to be a -1, 0. Okay, so now let's look at our radian measures. In the previous example, we looked at how to convert our degrees to radians, but we can look at it again. So to convert from degrees to radians, we're going to multiply our degrees by pi over 180. So let's start with 120 degrees, multiply by pi over 180. Well, I note that both of these numbers are divisible by 10. So I would cancel my zeros. And then I notice here that also 6 is common to these two numbers. 6 divides 12 twice, and 6 divides 18 3 times. So this gives us 2 pi divided by 3. So I can put that here, 2 pi divided by 3. Now I'm going to look at 135 degrees times pi over 180. Okay, so now, since this is in the middle, I'm going to say these numbers are divisible by 45 degrees because they're increments of 45. Now I know that 45 divides 180 4 times. And so if you were to use your calculator, you'd see that 45 divides 135 3 times. So this is going to be 3 pi over 4. And in case you're wondering, after I simplify, I multiply straight across. Now there are people who feel more comfortable with multiplying across and then simplifying. That's perfectly fine. Okay, now this would become, here we'll have 3 pi over 4. Now let's look at 150 degrees. So if we do 150, we have 150 degrees times pi over 180. Again, I can use my 10. And then I see, well, 3 divides 15 5 times. And 3 divides 18 6 times. So this gives me 5 pi divided by 6. I can plug that in here. Now, let's look at 180. I'll put it up the top here. 180 times pi over 180. Well, would you look at that? 180 cancels. And so this is just going to be pi very important thing to note, that 180 in radian measure is going to be pi. Okay, and that's your second quadrant. Yay. Okay, we're going to do the same thing for the third quadrant, but instead we're going to be using the x-axis. So now my x-axis is going to be symmetric, or my line of symmetry, if you may. This is going to be my mirror. So now I'm going to flip down, if you can imagine flipping down. So I'll have an angle that's 30 degrees away here, right? And so recall that this is going to be symmetric, or it's going to be a mirror reflecting what's at the top down here. So this is going to be negative root 3 divided by 2, 1/2. And then I'm going to leave a little space here, and you'll see why in a few. Again, we're going to do the same. We have your middle angle. That's going to be corresponding or reflecting for my middle angle at the top. So this is going to be negative root 2 over 2, again root 2 over 2. And then the last one, and this is going to be reflecting the one at the top here. It's going to be coming all the way down to this one. So that's going to be 1/2 root 3 over 2. Now, the reason why I left a little bit of space is because just like how we took into effect when we're in the third quadrant, that we looked at when we were in the second quadrant, that you'll have your x negative and your y positive. But if you're in your third quadrant, your x will be negative and your y would be negative. So these would both be negative values. So now let's come up with our degrees. Same method that we used before. So this angle is just about 30 degrees away from 180, right? So to get what that angle measures, we would do 180 plus 30. And that's going to give us 210. So this is going to be 210. And then our next angle is going to be 180. This is going to be your 45-degree angle correspondence. And that's going to give us 225. And then we'll have 180 plus 60, which is going to give us 240. Okay, now that we have those, let's look at our radian measure. Okay, let's make some space down here. All right, so let's look at it here and then we'll go back up. So we have 210 times pi divided by 180. I see my zeros, so I'll cross those out. Alrighty, so 3 divides 21, 7 times, and 3 divides 18, 6. So this is going to be 7 pi over 6. So I'm going to do all of them, and then I'm going to go back up. So then we have 225. 225 times pi over 180. So again, recall that this is going to be my 45-degree increment. So that means that 225 must be divisible by 45, right? And so 225 divided by 45 is going to give us 5. 180 divided by 45, well, that's going to be 4. So this is going to be 5 pi over 4. And then we have 240 times pi over 180. My zeros go. I can use 6 actually. 6 divides 24 4 times. And 6 divides 18 3 times. So this is going to give us 4 pi divided by 3. So I can now go up and plug these in. So for 240, we had 4 pi divided by 3. Okay, and then for 225, we had 5 pi over 4. And then for 210, we had 7 pi over 6. So we have one quadrant left. But let's not forget, here at the bottom, we can also fill this in. So, of course, we are still going to have 1, or unit 1 for the radius. But we're still going to keep in mind that we're at the bottom. So this is going to be 0, -1. Now, also recall that this angle is going to be this angle here. It's going to be 30 degrees, right? Because it's corresponding to that 120. And so 120 and 90 share a 30-degree increment. So 240 and whatever this is going to share also a 30-degree increment. So that means if you do 240 plus 30, that's going to give us 270. So this angle is 270 degrees. And so now we can also determine the radian measure here. If we do 270 times pi over 180, well, I can use, again, 10. So I'll have 27 and 18. And so we can use 9 here. 9 divides 27 3 times, and 9 divides 18 2 times. So this is actually going to be 3 pi over 2. Alrighty. Now we're ready to do our last quadrant, quadrant 4. You should pause the video and try. But if not, let's do it together. Okay, we're still doing the same thing, but now my mirror, do you want to guess where it's going to be? My mirror is going to be here. Did you guess that right? Very good. My mirror is going to be my y-axis. So I'm now flipping. So if I go here, this is going to be a mirror for this point. So this is going to be 1/2 √3 over 2. But I can also use the fact that I should know, right? I should know what my signs are. So if I'm in the fourth quadrant, my x is positive and my y is now negative. Now let me just make some space here so that we don't get too confused here. So this point is going to be 0, -1. And this point, now my x is positive, so it's going to be 1/2, and my y is negative. -√3 over 2. Okay? Then let's look at our 45-degree angle. That's going to be corresponding with our 240. Not 240, 225. Sorry. So now we know that this is going to be √2 over 2, √2 over 2. But again, my y is negative. And then lastly, I'm going to have here root 3 over 2 negative 1/2. Now, all we need to do is determine the radian measures. Oh, wait, no. We have to first determine our degree measure. Okay. So again, using the fact that these two should have a 30-degree difference, this would be then 270. So we're going to have 270 plus 30, right? So this is going to be 270 plus 30. That's going to give us 300. How about, as we do the degrees, we convert it to radian? So 300 times pi over 180. We cancel. And I can use 6 here. 6 divides 30 5 times. 6 divides 18 3 times. So this is going to give us 5 pi over 3. So let's plug that in. Okay, now remember the middle corresponds to a 45, so it's going to be 270, right? So we're going to be 270 plus 45. So let's do that. So 270 plus 45. That's going to give us 315. Now, so let's convert 315 to radian measure. Remember, since it is a multiple of 45, then 315 must be divisible by 45. And so if I divide 315 by 45, that's going to be 7. And we know that 180 divided by 45 is 4. So this is going to give us 7 pi divided by 4. So I can plug that in here. And then the last angle, if we recall, that's going to be 60 degrees away from 270, right? Let's go up. It's going to be corresponding to that 210. And so since 210 is 60 degrees away from 270, well, that means our last angle is going to be 60 degrees from 270. So we would do 270 plus 60, and that's going to give us 330. Now, let's convert 330 to radians. So that's going to be my pi over 180. I can use my zeros there. 3 goes into 33 11 times. 3 goes into 18 6. So this is going to be 11 pi divided by 6. All right, so let's see. So if we recall, this is going to be 330 degrees and 11 pi. So 330 and 11 pi over 6. Okay, so now I think we know what this is going to be. It's a complete revolution. We are back at where we started, complete 360. So this is 0 degrees, but it's also 360 degrees. And there are many ways you can figure out what the radian measure for this is. You can think about the fact that this is halfway of 360. Or if this is my pi and this is halfway, then if I do 2 times pi, I'll get the radian measure here. So this is going to be 2 pi. So a good rule of thumb is that 2 pi corresponds to a complete revolution in that 2 pi represents your radian measure. All right, that's it for deriving your unit circle. And so this is how we can use just the first quadrant, or just knowing the first quadrant, to help us to come up with the entire unit circle. Stay tuned. In the next video, we're going to look at how we can actually remember this.